Okay, hello. Welcome to chapter 3. Chapter 3 is going to be about solving system of equations. And all that really means is we're going to have a couple of equations. A system just means you have two equations. So here we have two equations involving x and y. And we're going to be solving a system which just basically means trying to find an xy pair that works for both of those equations. So our answers are going to be like x3 and y5. That's what you're going to get when you solve a system. So there's going to be a few different methods here to start the chapter for solving a system, two equations. We're going to do a graph method today, and then later we'll learn two other methods, one called combinations and another one called substitution. Okay, and maybe you've seen these before in Algebra 1, so hopefully some of this will be review. There should be a note sheet that goes along with today's lesson. If you do not have that note sheet yet, talk to the substitute teacher and you should be able to get it. But you can just take the notes, fill them in as we go here. At the top of the sheet, if you want to pause the video for a second, write down our goal of solving a system of equations. And we're not really going to use tables much. We're just going to use graphs. So solving the system equation using the graph method. All right, so a couple other quick notes. I briefly mentioned this before. A system is just a group of two or more equations. So you can see on this slide, we've got a system because there's one equation, two equations. So fill that in the note sheet. All a system is a group of two or more equations. To solve a system simply means to find an xy pair of numbers that works for both of the equations. Individually, each equation has infinite solutions. There's infinite xy pairs that work, say, for this first equation. I'm going to pick a couple x values here, and if we just plug them in into the equation, we have 2 times 0 minus 5. So when x is 0 in this first equation, y is negative 5. If you make x1, negative 3. If you make x2, it would be 4 minus 5. If you make x3, it would be 6 minus 5, 1. Okay, and we could keep going forever and ever and ever, and listing all the possible pairs that work for that equation. Okay, so individually it has infinite solutions. You try. For the second equation, make x 0, 1, 2, 3, and figure out what is the y value that goes with that. Give you a second, pause the video, and give it a shot. Okay, so you can check your answers. Hopefully you filled these in already. Pause the video and tried it. When x is 0, you get 3. When x is 1, it'd be negative 2 plus 3. When x is 2, it'd be negative 4 plus 3. And when x is 3, it'd be negative 6 plus 3. Okay, so again, we could go on and on and on here. But the solution to the system is the xy pair that works for both of the equations. So individually, they have infinite solutions for each of them. But which pair do they share? So I'm going to give you a second and see if you can figure out which xy pair is the solution to this system. Which one do they share? All right, and so the solution to this is the xy pair that are in both, that work for both equations. So our solution to this system is x2, y, negative 1. Okay, so we solved the system. We found the xy pair that worked for both equations, but pretty inefficient, right? We kind of got lucky that we found a matching pair here. We maybe would have had to list forever and ever. Maybe they don't match until x is 20 or something, so we'd make it a giant table. So this table method is not super effective. So this was just to kind of introduce and show you what does it mean to be a solution to the system. Okay, and the actual method we're going to use is called the graph method. All right, so we're going to do that same system we just got done doing, but instead of doing a table, we're going to graph. Okay, and the idea of the graph method is basically we're just going to graph the two equations, and we're actually going to use the Desmos program to help us graph them, and then the solution is the xy point where the two lines cross at. All right, so to solve them with graphing, you just plot the two lines and figure out where they cross. And this is pretty easy to do with that Desmos program. All right, so in homework, you'll just graph them on Desmos and then sketch what you see and label the solution. So this is going to take a little bit of advanced technology here, but make another tab and open this Desmos. All right, and you can just Google search for Desmos. There's a link on our school page, but I think it's just as easy if you just go in here and type Desmos. Just Google search it, and the first thing that comes up is the calculator. And just click on that and click Start Graphing. All right, and then if you want to look on your note sheet and just graph those two equations. So we're going to do y equals 2x minus 5. So just type it in, y equals 2x minus 5. Click down here to get a second line. And now we're going to do y equals negative 2x minus 3. So I know this is some advanced clicking around here, but hopefully, Justin, you can handle it. All right. So there we go, graph the two equations, and again, our solution is going to be where they cross. So Desmos is kind of nice. You can actually just click that point you want to find. Right, I'll zoom it in here a little bit, but just double click on it, and you can see that our solution is x2, y negative 1. So in homework, all that I'm asking that you do is just kind of sketch what you see. So label that point of intersection, and then just graph the two lines. All right, so ours looks something like this, where it crossed at 2 and negative 1. Okay, so just make sure you clearly indicate that your answer is x, 2, and y, negative 1. Okay, so it's really not any more advanced than this, other than there's one more twist, because math can never be super simple. It's always got to make things a little bit hard. And so this next example, same idea. We want to graph them, find where they cross, but what's different? See if you can figure out what do we got to do different on this one. So hopefully you figured out that the difference is to graph them, we got to put them in y equals form. So we're going to take this first one and minus 3x from both sides. So before we graph, we want to have them in y equals form. Second one, a couple steps, going to minus x from both sides. So we have negative y equals 7 minus x, and then divide by negative 1. So we get y, and then everything divide by negative 1 over here, which really just changes the signs. Okay, and now we're ready to graph. So have them on your sheet and load up Desmos again. So it's going to be 5 minus 3x for the first line, and then negative 7 plus x for the second line. Negative 7 plus x. Okay, and it looks like we got to scroll around a little bit. We're trying to find that point of intersection. So I'm just going to scroll down, take a look at it, click it, and it looks like they meet at x3, y, negative 4. So I'm going to record my answers here of x3 and y, negative 4. Okay, one thing that's kind of nice about solving a system is if you want to make sure your answer is right, so we can kind of check, and this only takes a second. So this xy pair should work for both of these equations. And so if we want to check quick, if we put in x up here, 3 right here, and y of negative 4, we would have 9 plus negative 4, and we could see that that gives us 5. So that first equation works out. If we try the second one, it's 3 minus negative 4, and we can see that that does equal 7, right? So we can kind of tell for sure that this is the right xy solution to that system. Okay, this is the last one for you to try. Okay, so I'm going to see if you can solve the system by graphing. Start by getting y alone, type them into Desmos, and then find the point of intersection. So give this one a shot. Okay, back with you to check your answer here. So first one, take away 3 x's to get y alone. Second equation, to get y alone, add 2 x's to both sides, so they cancel here, and we have y equals negative 7 plus 2x. Now it's graph time. Flip on over to our handy tool decimals. That makes math beautiful. 3 minus 3x, I believe is what that one was. And then negative 7 plus 2x. Negative 7 plus 2x. Kind of scroll it around, find the point of intersection. Looks like we get the intersection point of 2, negative 3. So we'll just record that on our sheet. We got x equals 2, y equals negative 3. And if you want to write it this way as an xy point, that certainly works too. And just again, as a sanity check to make sure that everything's okay, we could check it out. We could do 3 times 2 plus negative 3. Does that equal 3? Sure, we get 6 plus negative 3. That equals 3. It's good. And the other one, checking it out, coming down here and checking, we'd have negative 2 times 2 plus negative 3. Does that equal minus 7? And we could see negative 4 plus negative 3. Boom, that equals minus 7. So we can tell we got the right solution to the system.